Okay, guys, third and final lesson of the week, solving logarithmic equations without the one-to-one property. You might see W-O-U-T, wout. Oops, I didn't mean to tap that. It should say without, whatever, little typo. There's other typos I've noticed, but I don't dwell on that, and neither should you. So, okay. So yesterday, or well, what should be yesterday, I don't know what order you're doing things in. We did 3.5 solving with the one-to-one property, where you basically cancel logarithms on both sides. The question is, what if there's a logarithm on one side but no logarithm on the other? How do you cancel out a logarithm so that you can isolate a variable? So that's what we're going to be doing. We will have some problems where there's exact answers, and we'll have some answers that are rounded to like 4 decimal places. Today there will be no extraneous solutions, so we don't have to have that hassle like we did on the previous lesson. Before we get started, why did we start using logs? It wasn't that long ago, it was just last week, exponential equations. Why did we start using logs? Well, it was born out of the necessity to cancel out a base. If you want to isolate a variable and that variable is part of a power or an exponent, you need to cancel out a base. And what does it take to cancel out a base? A logarithm. A logarithm was sort of the invention to cancel out a base. You do it to both sides. And then you work this out using a calculator if you need to, or maybe you can do it in your head. I know the answer is 3 because 2 times 2 times 2 equals 8. Yeah, how many of these does it take to equal that? That's one way to think about a logarithm. So there, we started using logarithms to cancel out bases. Well, if a logarithm cancels out a base, what cancels out a logarithm? So if we have log base 5 of x equals 9, how do we cancel out a logarithm? If a logarithm cancels out a base, then do you see where I'm going with this? If a logarithm cancels out a base, then a base cancels out a logarithm. So as we go through this set of exercises, every problem is going to have a logarithm that we're going to need to cancel out, but there's not one on the other side to cancel. So we're going to do a method which, this is not official. You're not going to find this in a textbook at all, but I like music, and this totally relates. So we are going to drop the base. B-A-S-E instead of B-A-S-S, so it's not that kind of base, but still, drop the base. So let's just do examples. So you're going to learn through examples here, not a lot of lecture as far as like the notes up here. Okay, so log base 9 of a equals 1. How do you solve for a? How do you cancel out that logarithm? Well, you put a base down here. So it's like 9 to the some power. The power is now this side of the equal sign. So the 9 is a base, and all of a sudden this is an exponent, or a power. And like always with equations, what you do on one side, you have to do on the other side. So we drop a base 9 on the other side. So now this 1 is a power. These cancel out. Base 9 and log base 9 cancel each other out, which gives you a. And right, that's the whole point. We want to isolate the variable. Over on the other side, we get 9 to the first power, which I hope you can do without a calculator, but let's just pretend you don't. What is 9 to the first power? Oh, it's 9. And there's the answer. And just like that, we're done. Number 2. Wow, this is a long worksheet. 9 right there. All right, if you didn't catch that, if it didn't make sense, we'll do another. Number 4, coincidentally, is also base 9. Man, are there a lot of base 9s? No, it's just apparently the first 3 problems on my side. So number 4, we want to cancel out a log base 9, so I have to drop a base 9 here and do it here. Those cancel out. I get r plus 3 equals 9 to the 0 power. What's 9 to the 0 power? Well, anything to the 0 power is 1. R plus 3 equals 1. Now subtract 3 on both sides. R equals negative 2. And then that is the answer. Let's check number 4 and see. And there it is. Now remember, we talked about logging a negative number is undefined, but keep in mind, if we were to plug this back in, negative 2 plus 3 gives you positive 1. So we're not violating any rules here. You can still log a positive number. All right, so to cancel out a logarithm, you drop the base. Whatever, oops, didn't mean to do that. Whatever this base is, you put it down here, and you do it to the other side. Now, what's the difference between number 4 and 6? I mean, obviously there's a few differences. R versus X, you have a 0 here, you have a 6 there. But one thing that should jump out at you are the parentheses. Down here, this 3 is not in parentheses along with the x. That means that 3 is not part of the logarithm. It's not part of the argument. So the first step I need to do on this problem is subtract the 3 to move it over to the other side. So that 3 and 6 are essentially like terms, and you have to combine them. Now I can drop the base 9 again, coincidentally. They're not all base 9s. And I get x equals 9 to the third power. And what is 9 to the third power? 279. X equals 279. So let's check number 6. There we go. Let me look at the evens for just a second, even though you're supposed to do this. So how do you cancel out a base 6? You drop a 6 here, and you drop a 6 there. And then you need to use your calculator for this. How about this one? Oh, what's this base? You don't see it. Remember, if there's no base explicitly written, you assume it's base 10, so you're going to drop a 10 on both sides on that one. This one, you're going to subtract 6 over to that side first, and then you'll drop a base 2 to cancel out a base 2. So I don't usually start going over even or odd problems, but a little worried that this might be confusing. So a little heads up on how to start those. All right, let's look at number 8. So we do have like terms here, 9 and 9, so I'm going to go ahead and subtract 9 on both sides. I get log base 12, v plus 7 equals 0. Now, can I subtract 7 on both sides to cancel that out? No. That 7 is in parentheses. It's sort of part of the logarithm, part of the argument. We cannot touch that 7 until we cancel out the log. How can we cancel out a log? Well, drop the base. It's base 12. You have to drop a 12 here and over there. You get v plus 7 equals 12 to the 0 power. Now, do you remember a minute ago, anything to the 0 power? Oops. 12 to the 0 power is 1. Subtract 7. V equals negative 6. And I'm not going in to manually plug these in because you don't have extraneous solutions on problems like this. So number 8, negative 6 right there. All right, number 10. Now this is one that could confuse people. I could see people who want to drop a base right away, but you can't because this negative 9 out here, it's not part of the logarithm. We need to get rid of it first. I could see people who see a negative 9 and want to add 9 to both sides. That won't work because it's not subtraction, it's a negative. It's actually multiplication. And how do you cancel out multiplication? It takes division. You have to divide this by negative 9 to cancel that out and do the same on the other side. So we get log base 9, negative 3x minus 2 equals 9 divided by negative 9 is negative 1. Now we can cancel out the logarithm by base 9 again. Wow, I should have proofread this worksheet a little better. There's too many of the same type of problem. So I get negative 3x minus 2 equals 9 to the negative 1. All right, let's talk about 9 to the negative 1. I think this is going to come up in your homework. 9 raised to the negative 1 is a nasty, ugly decimal. If I check number 10, is there any decimal anywhere? No, there isn't. So what does that mean? Well, it means that we have to treat it as a fraction. All decimals have a fraction form. If I hit the fraction button on Desmos, now can you see, look at the screen, can you tell what I'm pressing there? Obviously you can't see my finger and what it's touching, but that circle with the little fraction symbol, box, fraction bar, box, converts it. So this is negative 3x minus 2 equals 1/9. Or you might just remember the rule from algebra. When you have something to a negative power, it flips it and makes it the 9 into 1/9. I mean, that's a thing. That's something you're supposed to know also. All right, so now I need to finish this. So I need to add 2 to both sides. Negative 3x equals, what's 2 plus 1/9? Well, I can take this previous problem and put in plus 2. It looks like it's 19/9. Now I have to divide both sides by negative 3. So now I need to do 19 ninths. My gosh, I'm doing everything wrong. 19 ninths divided by negative 3, and then hit the fraction button. Negative 19/27. Okay, so that was a lot. Look, the steps we did were not particularly difficult. I mean, we added, subtracted, multiplied, divided. Dropping the base is new, but once you learn how to do it, it's not what I would say difficult. Having the hassle of the negative power, making it a fraction, that's kind of taxing on the brain, but you got your calculator that does this, so that's not so bad. And really, you should be able, by the time you reach pre-calculus, you've done this math stuff a while, you should be able to work your way through this and be successful. I say successful without checking the answer. Let's make sure that I did it right. Okay, I can legit call that a success. Let's look at number 12. So it's not base 9, yay. Add 4 to both sides. 10 log base 6 of 1 minus 6v equals 20. This is 10 times the log, so I'm going to divide by 10. Log base 6 of 1 minus 6v equals 2. To cancel out a logarithm whose base is 6, I have to drop a base 6. That'll cancel out. I get 1 minus 6v equals 6 squared. And I'm going to go ahead and make that a 36, because I know that. That's easy, 36. Minus 1, negative 6v equals 35. Divide by negative 6. And 35 is not divisible by 6, so I can just bring the negative out and call that good enough. Let's check. Negative 35/6, and there it is. We're on a roll. Now look, the rest of these answers have decimals. What's up with that? Well, it just comes down to reading the instructions. Round your answers to the nearest 10,000th. So that means 4 decimal places. So number 14. I need to get rid of that 6. That's times. I'm going to divide it. So log 6 of negative 7v equals 18 divided by 3. Drop a base 6 to cancel that out. Negative 7v equals, what is 6 to the third power? I think it's 216. Yeah. Now divide both sides by negative 7. Now in a pure math sense, you could leave your answer 216 over 7. But some people aren't into pure math. Some people take this job called engineer, and they really need decimal values. So 216 divided by 7 is negative 30.8571. So check number 14, negative 30.8571. There it is. So it's not a big difference between the two different types of problems. Let's do number 16 and we're done. Add 9 to both sides. 8 log 11 negative 10k minus 7 equals, what is that, negative 8. To cancel out that 8, I'm going to have to divide it because it is multiplied. Log base 11 of negative 10k minus 7 equals negative 1. To cancel out a log base 11, I drop an 11. Cancel that out. Negative 10k minus 7 equals, what's 11 to the negative first power? Well, I know that it's going to be 1 over 11, but since we're all about decimals right now, 1 divided by 11 is 0.0909. Add 7 to both sides. Negative 10k equals 7.0909. Okay, that does not look like a plus 7. Divide both sides by negative 10. So 7.09. Wow, this thing is not cooperating with me. Divided by negative 10, negative 0.7091. So I'm following rules of rounding. That should be right. Hopefully I didn't mess it up. Yeah, I felt like I was fumbling through that whole thing because the calculator wasn't working for me, but there we go. Okay, so what I'm asking you to do is very much like what I did. So work your way through this. Don't be tricked or fooled by the fact that this is base 10. We'll eventually be doing some more of this because we're going to do it with e and some natural logs. But for now, this is about it. So do the assignment, check yourself, contact me if you have questions, and I will talk to you later.